Okay.
There you go. Now, if you sit in a chair, it should line you up appropriately.
Oh, okay.
I had to pop out and get back in.
And
to make
if
mine
you go
work
into
again.
seated mode, simulated standing.
Yep, I'm
Ken,
in seated
sometimes-
mode, yeah.
Okay, excellent. And then you just
Okay,
aim.
I'm going to record this,
when you see the
guys,
sit
if you
thing,
don't
you gotta
mind.
back away from the chair. You're going to sit in a little bit. There you go. Perfect. You look great.
All right.
I want to sit up here though.
Okay.
It's not catching it.
Hold that
All
teleport
right.
button
All right.
down.
There we go. All right, there
you
we
go. You got it. Cool.
Okay, everyone
All right.
good to go? All right, it is my great
All right.
pleasure, after a few short minor delays, to introduce to you Gabriel Rene, author of The Spatial Web. And I'm not going to take up too much of your time, but Gabriel, thank you so much for persisting through traffic, through login hell. Here we go. Let's
You're welcome.
take it away. Gabriel, thank you so much
Yeah.
for joining the 2020 Educators in VR International Summit in the Moon Base.
It's a pleasure to be here. I had no idea that there was so much traffic, LA traffic on the way to the moon. So that's a first. Thank you all very much for attending. This is a really exciting opportunity for us. These are the early days, the very first sort of websites, if you will, where we get to have these collective experiences, almost the chat rooms of the early web. And what I'm going to talk about today is the spatial web and how this emerges and evolves into fully networked, immersive revisioning of the entire web, and in practice, a revisioning of the world as well. So I'm from a company called Versus. Let's see. Oh, this didn't quite work. Hold on. And we developed underlying technologies to power this next generation of the web. When we talk about Web 2.0, we're describing a web that we're all quite familiar with, but it's distinctively different from this kind of experience. You know, it's a two-dimensional web behind the screens. It's a web of pages and text and media. But Web 3.0 really becomes a three-dimensional web in the world. And whether that's digital content in the world around us, or us in digital environments, it's a web of people, places, things, and the transactions and interactions that we have. It's fundamentally spatial, and it shifts our entire paradigm. It's a multi-dimensional change in our relationship with our information, and therefore our relationship with each other, with the world around us. Peter Diamandis is one of our advisors. Recently wrote a book called The Future is Faster. It talked about the accelerating pace of these emerging technologies and their impact. There's an entire chapter in there about spatial web. And Peter has said about us, you know, in the same way that trillions of dollars of value was created on the two-dimensional web, versus creating the three web protocols upon which the company's capabilities, platforms, and let's say even the teaching and learning environments of the future will be built. It's just an indication that some of the top futurists in the world are seeing the vision that we're seeing. Let's talk about the key trends that are driving this shift. So we kind of look at this classic computer science architecture, which really makes up both our computer stacks as well as our networks. And it turns out it's very repeatable. There's always a data tier, there's always a logic tier, and there's always an interface tier. And along the top there, you see sort of these trends in computing, the sort of corporate era, the personal computing era, the mobile computing era, the spatial computing era. At the bottom there, you see that there's always been these various protocols that connect these three stacks, these three parts of the stack together. TCP/IP, the underlying protocol that drives the internet. HTTP, which was hypertext transfer protocol, invented by Tim Berners-Lee, in about '91, from the work he did out of CERN in Switzerland, and eventually they thought that it was so useless that they kicked him out, and he had to go to Negroponte over at MIT, and he said, "Hey, we got a spare room back here. Why don't you see what you can do with this thing?" And from something that really had almost zero budget, almost nobody working on it. No marketing team, no operations team. It's grown to be the most powerful single protocol in the world, connecting all of us in amazingly powerful ways. But there are limitations to it. It's fundamentally about the text-based networking protocol for a document-based web. It's a web of words. It's not a web of worlds. And so the spatial web starts to take these same trends, this data trend, this logic trend, this interface trend. And if you'll notice some interesting things at the bottom, go from localized data, where the data storage and the data compute is in one big building, right? And over time, that becomes more and more distributed and more decentralized. Today, we're talking about blockchain and edge and mesh computing, where both the compute and the storage are distributed themselves. You look at the logic tier, we start with custom programs, where we're programming computers in their language. Now, computers are programming themselves. They're doing their own custom programming. They're starting to become adaptive, smart applications of the next era. And then the interface tier, we go from really 2G sort of difficult plug and play, ways of interacting with computers to like data entry through typing on little letters on a keyboard. The mouse is pretty powerful innovation to the multi-touch screens of today. And then we all know we're talking to Alexa, we're talking to Siri, we're moving into spatial interactions, gestural, computer vision, chat bots, and pretty soon, the cameras themselves and the power of these new interfaces with augmented and virtual reality glasses. I mean, today I'm wearing a headset that is not connected to a wire, and I have full tracking of my hands just from essentially a $400 piece of hardware. It was just impossible even just a year ago. So this is rapidly accelerating. So trend number 2 is that we're actually already moving into the spatial web. The spatial web has already kind of have these like Web 2.5 applications, and we're already seeing billions of users adopting these. So if you think about Airbnb, Uber, by adding geolocation and GPS to our hands, something our laptops didn't have, we're suddenly able to build these sort of digital twins of our homes, which we can rent out, or digital twins of cars that are able to take us from point A to point B. Postmates. These are all services that now rely on a new context, which is a location context, a new dimension that wasn't in our previous computers, wasn't part of the personal computing era. And then, of course, you have Uber, you have Snapchat, where you've got digital twins of people, and we're starting to overlay, avatar-like characters, like we're presented today, but in an AR fashion. Of course, AR and VR and MR, whichever terms like to call it, is all going to intermix and overlap. And then you've got your Pokemon Go's, and now the emergence of AR Cloud. In the industrial settings, you're starting to see Magic Leap and other companies really focused on connect you in industrial spaces, warehouses, and medical facilities. You have what are called building information models in construction, and of course, these are 3D models that are using Autodesk and others like Unity now with their new Reflect platform. You can see these trends around spatial adoption are actually already there. We're in the sort of Web 2.5 era as we're quickly moving into Web 3.0. And then trend number 3 is that we used to just digitize words. We used to digitize our documents. And now we're digitizing everything. Your iPhone is using 30,000 points to track the contours of your face. That's how it unlocks. It's building a spatial model, right? And there's your LiDAR scanning and SLAM maps that the phones are using now to do augmented reality, project characters into environments. See other digital things and assets that are being made in Autodesk. Everything that we use today that's been designed inside of a computer in a 3-dimensional environment and then gets created as a physical object. So we're actually starting as a 3D first. And actually with the dawn of cryptocurrencies and blockchain, we're now having digital payments that are starting to enable real-time programmable transactions between party A and party B. I'll get into that in a little bit here. So, So sometimes people like to use the term Web 3.0. We say that Web 3.0 is the spatial web. but others talk about the term Industry 4.0. And the Japanese, in fact, they're talking Society 5.0. But all this is talking essentially just about these paradigm shifts that are occurring, and in part have to do with the emergence of these new powerful, what we call exponential computing technologies. And so there's IoT, trillions of devices that are merging over, drones, automated vehicles, Roombas. You've got augmented and virtual reality, so spatial computing. You've got artificial intelligence, deep learning and machine learning. We've got mesh and edge compute, which is pushing these devices to the edge. Distributed ledger, which is a blockchain and new ways of storing information, and cryptocurrency. So these are kind of the usual suspects that are the ingredients that become the cake of this new cake we can call Web 3.0 or the spatial web. But really the question is, if these are the ingredients, how will they work together? Well, we know they're converging, but how are they actually going to converge and become part of a network? Convergence is not a network. Networks mean that we can talk and communicate, and there's protocols under which we can communicate back and forth with each other. So we start to think about cameras tracking our every movement, or biometric data even being tracked from the headsets or handsets that we're wearing, we're using right now. The fitness apps and wearables that every company is getting into, and then content being projected into the world, or 3D assets being created here, the ownership of this space or this building, and who has the right to change it, or remove the seats, or quadruple the seats, or decide who can and who can't come in here. How do we create spatial policy that works in the physical world where it's digitally mediated, and where we're taking the physicalization of digital things and recreating them in virtual space? How do we trust any of this spatial activity? This is problem number one. It's really the who, what, where, when, and how of all spatial activity, whether this is robots constructing a new building in Dubai, or the interactions that we might have in this environment. How do we create policy? And how is that policy interoperable across different environments and different worlds? And when should it be and when shouldn't it be? So this is problem number one. Problem number two is, how do we network it all together? People, places, things, activities, money, different platforms, different headsets, different back-end servers. I mean, it just seems overwhelming and kind of impossible. Well, it's not. But we need our new standards. And it turns out if you have a very simple set of universal things, you can in a rather straightforward manner, create networks. So networks essentially need a couple of ingredients. If we look at the web today, very first thing we get are web domains. Now, you may not know this, or you may, but the domains started before the World Wide Web. So in around 1985, the very first domain was created, and pretty much .edu and .com were the first two, and then .net came along, and then later we've got more and more .org, and now today we've got .vr and .io and .ai and .musim and whatever you might imagine. But those addresses were what the URLs were built on, right? There's an entire economy around these domain names. So you need an address. You need a way to program an environment, kind of set the layout, set the rules. This is what HTML was, the hypertext markup language. You need a protocol. There's some way to network and communicate between these things. Hypertext transfer protocol is what we use today. And the web of today is stateless, meaning that it doesn't capture the clicks that you make. But companies do, don't they? And that's how they actually monetize all of the value. The web is stateless, but the applications capture the states, those events that you do, what you're looking at, what you're browsing, or what applications you're using. Today we have location data that's being tracked. So let's look at this through the lens of the spatial web. So then if we wanted to build a spatial web but copy this same sort of structure, we would need spatial domains. Now, these wouldn't be domains that are sort of virtual domains for pages. It would be environmental domains, spatial domains like this room, right? We would need an address that isn't a street address, right? We need an address that's volumetric, the shape of this room, so that we could decide who could come in and who could come out. We need a way to sort of program these activities, and we wouldn't use hypertext because it's spatial, so we'd use a hyperspace modeling language. This would define who could perform what activities, where they could perform them, in what way, what the restrictive behaviors or prescriptive behaviors. And then we need a protocol, not a hypertext protocol, hyperspace protocol, which we call hyperspace transaction protocol, that would then enable these various data, logic, and interface technologies to be able to communicate. We do that today. Our front ends talk to our back ends, and we're able to program in many different languages, all kinds of activities. But we need to move beyond screens into the scenes of the world around us. So we're going to walk you through this. Start with spatial domains. So what does a spatial domain look like? It looks like this. It doesn't have to be cube. It doesn't have to be a rectangle. There's sort of a simple way to think about it. What's cool about spatial domains is if you think of them, domains are about rights management. So if you own, say, educatorsinvr.com, and you're the owner or the administrator, you get to decide what happens on your page. You can say, when you come to my page, you can't see any. Or when you come to my page, you can see some things, but if I don't know who you are, this is all you can see. But if you log in, you can see this. If you give me a credit card, I can give you access to this stuff. That's exactly the way that you can program spaces. Well, I don't know you, so you have to hang out here, or you can only see these things in this environment or in this room. Oh, I know you. Okay, well then now you have access to more stuff. Or if I have more data that you might provide me, you have access to a VIP area, or you have access to other assets. It's the same. But now you're able to do it in the physical world where you have digitally mediated content and information. You can define where robots can and cannot go. You can define which AIs can look through which cameras into which rooms. You can define which IoT sensors have the right to track information in the room, temperature or lighting or motion. You can set policy for this, right? And you can do the same thing in a virtual reality environment. Who can enter, under what terms, do I know you and not know you? Can you leave information here? Like, can you comment on my page? Well, can you comment in this room? Can you leave it? Do you see the parallel? I'm seeing everyone nodding, yes. Good. Of course, you can do this citywide, but you can do this across entire nations or planets or worlds. We'll walk through that in a bit. So those are the new kinds of addresses, very important. What we get from that is smart space. Not just smartphones or smart wallets or smart cards, it's smart space. And smart space means that you can wrap this in a set of protocols. Remember we looked down before, it said the web is stateless. Well, the virtual worlds of today and the AR worlds of tomorrow can't be stateless. You might want to leave information or an object or an item or a character or a game somewhere, and it needs to be persistent. So therefore, we need provenance of who you are and who left it. This is an entire new identity paradigm that we need to deal with around objects and locations and users. And then, of course, you can leave persistent information subject to the rules of that domain rights holder. And that's how you do it. You set certain permissions that then determine who can do which things, who can create something, who can sell something, who can move something. And what's amazing was when you think about the physical world, physical things that are connected things like IoT are basically digitally mediated digital things that just happen to have a physical representation. You can program it digitally in physical activities. So you can set the parameters and say, well, the drones can fly over the park, but they can't fly within 3 miles of the airport. And the drones have a big sort of virtual force field right there. Literally cannot pass that zone. And finally, payments. How do you enable automated payments in the way that we do today? This is the basis of automation. You know, if there isn't an interoperable spatial web, then if I'm using my AR glasses of the future, I'm moving from VR world to the other. Is it only Amazon headset works inside Whole Foods, or can my Apple headset work inside there? They're going to be Google. The Google runs the ports of Los Angeles, and IBM is handling all the mobility. How do these smart cities of the future work if there isn't an underlying interoperability layer? All web spaces of the future to function on top of these underlying protocol structures So if you start to think of it in terms of smart space, then smart spaces becomes a web space. And those web spaces are secure, just like you have HTTPS today. There's also secure web spaces by default. Then you can add all the persistence of content, permissions for who can do what, where, and how, and payments that you can start to automate between different parties. So this is what the spatial web looks like when you just look at it from the sort of protocol level at the bottom, right? It's connecting each of the tiers. You see that? It's always been the same thing. This is mind-blowing stuff, but it's just a little bit of innovation. It's really just saying, let's add a new dimension, and then let's use the same functions that we've been using so far, but in ways that are natural and more intuitive, more intelligent and smarter and self-programming, and faster and more trustworthy and reliable because of spatial computing technologies, because of IoT sensors that can track information in real time, because of AI and smart applications that can start to execute on those things, because blockchain and edge can help secure our identities, our locations, our objects. We have trust in a way that we've never had on the web today. It was never built into it because they never thought that economies were going to grow on top of this, that social networks were going to emerge, that we would have multiple identities, a LinkedIn identity, a Facebook identity, a Google identity, a blah, 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 blah. Why couldn't I just come up here and start to present? I have to ask for Google's permission. The spatial web is not an environment where we can ask for permission every time we go somewhere, and one login from the corporate ID is not going to suffice. So we're going to need new ways of thinking about identity in the spatial web. So that was an address. It was spatial domains we talked about. And then we said, need a way to program the reality. Well, this is what we call hyperspace modeling language instead of hypertext markup language. And what do we get? Not structured data, structured space. That combination of digital and physical become what we call sort of phygital reality. I'm still trying that on. I'm not sure if it's brilliant or horrible, but let me know later. That's the matrix, right? And that's exactly what the matrix is. It's a spatially modeled environment. And that story, of course, the AIs figure out how to program that into the minds of humans. It's because we're born spatially oriented. So there's your programming language. What does that allow you to do? Well, let's look at the problem from a physical world perspective. Turns out the entire world is filled with very complex activities that involve people and places and objects and locations, and everything's moving all the time. And we try to manage our physical world, context of the physical world, that's a spatial context, with the administration of symbols. If you really stare at this, and you realize, we're on the moon, but if we're on Mars or we're on some other planet, and we had highly intelligent aliens that were trying to explain how we maximize our activities in the world. We said, well, we use these little squiggly lines, and they tell us where to go in space and what to pick up and who to take it to and why. I don't know, but I imagine they might look at us rather strangely. Like, isn't there a better way to do this? The problem is you've got a physical reality on the left and you've got a digital reality on the right, and they're two different contexts. Really. So you need a type of hyperspace modeling language where you get the benefits both. Right? Because the problem is we've got high information richness in these spatial environments, but then we translate that into symbols, we lose all that richness. And then we go, okay, well, at least now we can manipulate it. It's digital because matter is very difficult to work with. Now we can get all this high instructional richness. Well, ideally, you would go pick up this item and then move it over there and then move it to the truck. So, hey, Teresa, can you go do that? But then when we push it back into the world, we give it to them in symbols. So we have high instructional richness. We push it back in with low instructional value, right? We're losing the value on both sides here. We have a communication problem between two different worlds, and everything gets lost in translation. And of course, the solution is we'll just integrate the activities in the administration, the physical and the digital together, information richness and instructional richness. So a hyperspace modeling language allows you to program the physical world like you would a web page. And so what do you get? get something that looks like this, that both humans and machines can understand. Why? Because it's in the language of geometry. It's in the language of reality, in the language of physics. You've now boiled everything down to the universal primitives of reality. We've got a spatial context to start from. Of course, this is how we teach our children, right? We go like, here's a million pictures of dogs on the screen. Now figure out what a dog is, right? Learn everything spatially. In fact, before we teach them language, semantic, their first language is spatial. We teach language in three tiers. First, we teach spatial. Of course, we all learn that because we're designed biologically to tune into that. How the rest of the mammals and everyone else got us to this point, right? You start with spatial. Then we learn semantics. What does that mean? What is that object called, right? And then we learn social. Oh, who owns that? What's that worth? Oh, who's in charge? And so you got to combine the spatial, the semantic, and the social in a language that you can model them all together. Oh, what the object is, this is the shape, this is who needs to take it over there. When we take it over there, party A pays. So then you can design spatial workflows, right? You have digitally mediated, augmented reality that can just have a pick and pack worker, not look at a bunch of digits. Hey, Joe, go find item XJ4912. It's in row 17B, aisle 6, section 4A, and move it to the dock. What happens? We have a human mind translate symbols on a page into a spatial map in their brain, try to find their way through a 1 million square foot warehouse. Why don't you just draw an arrow and have them follow the arrow right to that, have a bouncing ball or that points them right to the object? And then guess what? Now both a human and a machine work together in some way. You can have humans and machines their behavior. This is exactly like, this is the difference between MapQuest and Google Maps or Waze. Even then, I'd like it outside the screen, just put it right in front of me, right? We all know that if we said, hey, I'm going to drop you off in a city you've never been in, right? In Turkey, like, I'm going to give Carlos here the Google Maps, right? And I'm going to give Lisa over there MapQuest, which is you have to print out like, turn left and then drive 1.5 miles and make a right on this street. Who's gonna get to the destination? Carlos wins that, right? Because we're designed to be spatial first. Spatial is going to win first every time in that case, right? So of course, what we've seen as we've deployed applications like this into these warehouses is up to a 25% performance increase. It's highly intuitive. In these environments, these pick and pack workers are often temp workers. They don't know this 1 million square foot space. Imagine the optimization over a multi-trillion-dollar market runs our global supply chain. What happens when you start to optimize that, even just with human enhancement before you get to automation? Billions of dollars in value. What did you do? Add spatial. Keep going. Spatial Web has more. So in that case, you get to a smart warehouse, right? And we talked about smart spaces before. Well, this is a type of smart space. It's like saying it's just a type of a web space. This one's called a warehouse space, right? And then here you've got automated picking carts, and you've got computer vision that's tracking things. You've got AI simulations over here, and there's a digital twin that this guy in VR can remotely be watching everything that's happening. And you've got robots bringing pallets around, and everyone knows where everyone else is, and no one bumps into each other, and it's safer and it's more effective. And wow, what did we do? We just turned one space in one industry into a smart space, into a web space, right? But of course, it's not networked with other spaces. Sort of like in the beginning of the World Wide Web, the big pitch wasn't, hey, go on the World Wide Web because there's going to be all this content people can write about you and link to you, and you're going to get all these network effects and all this traffic. No, it was, you're in the yellow pages right now. If you had a web page, you could at least just go and you could change it, you could update it. And when you just tell people to go to this one page, they'll have all the information about you. That was it. It was just better than the yellow pages, better than a business card, better than a pamphlet or a brochure. Web 2.0, everybody linked to it and wrote about it, and your product and your business, and talk good things about you and bad things about you, but that was really when the network effects kick in. In the beginning, it's just, can you make it better than what we have today inside my world? Yes. But then tomorrow, how do we connect it to others? And so to run through this, smart spaces or web spaces can obviously be factories, right? And humans and robots and AI and machines are all interacting in here, and there's digitally mediated holograms routing everybody around and driving this, and transactions are happening when a third party pulls up. And so you've got integrated supply chains that are checking in and checking each other out with transactions in a kind of relay race around the planet. Now, the output of this can also mean increased sustainability, because now there's basically more margin. Of course, this is a larger question about what we value in terms of our business and our societies, and what the spatial web impacts us globally. Smart construction. How about, why don't you put the entire BIM model, the 3D blueprint of the entire thing up, and I'll just follow exactly where I need to put that beam and where we need to put in that post and where we need to. And actually those robots can help, and the digital crane, the crane can help, and drones, hey drone, you can only fly here, you can only land there. Let's look underground and see which pipes are here so we don't blow up a gas main. This information suddenly becomes publishable and available and permissioned. So I can't see where the gas main is, right? Maybe Keith can, right? So mining, resource management, you start to see the whole thing. You see this little dotted line? Every one of these is under a spatial domain. So that's how you set policy for that. You decide, oh, who's a known entity who can come on this site? Watch out, don't walk here. AIs can start to optimize that. Smart oil and gas farms, right? Retail. So you take your stocking and routing people, they go in the back, they walk. How'd you like to walk into Whole Foods and just have it just route you to everything you want based on your profile of your new diet, right? All we do is wander around in stores. Who here has been to Home Depot? Please raise your hand. Depot, anybody? You ever get out of there within half an hour? Like, I need one thing. I need a screw or some duct tape. Ask 7 people. No one works there apparently anymore. Now, so you've got this whole opportunity to now have third-party people like Instacart folks who are starting to come in and do our shopping for us. And they just look through their screen or look through their smart glasses. It's going to route them directly to the product, right? And then as you walk out, you go collect what you want. Computer vision is tracking every product that you're pulling up. It recognizes who you are. You've given them consent to access your information. And then when you walk out, it's like when you step out of an Uber, what happens? Instant payment, digital payment, fully automated. You're walking in and out of stores, you're grabbing whatever you want, and it's charging you for it. Like, theft in the future sucks, it's expensive. Keep going. So what do we get here? We start to get a smart world, not just smart retail and smart warehouses and smart farms, right? Smart world, working together. So now we're starting to get these network effects, right? And if something happens and there's some sort of threat response, you can say all the drones are down in the city, or all the automated cars can stop. And because of the use of blockchain, you can actually do powerful things to ensure that those IoT devices are not able to be hacked very easily. Because in every domain that they pass through, the rights to those objects has to be permissioned. And of course, the city and the government have access to that and are able to set those as laws, as type of spatial laws. And so, yeah, yes, for those paying attention, we do get into a little bit of pre-crime Minority Report stuff here when this starts to roll out. You can imagine both the performance and the optimization that our cities, smart cities of futures, can actually really deliver on at scale. And then, fascinatingly, it turns out the whole planet runs on these supply chains, right? We take things out of the ground, we turn them into raw materials, we build products out of them, we ship them around the world to each other, and then we consume them in some way. Now, of course, responsibly, we probably need to all think about that entire cradle-to-cradle cycle, and how does it go back into the ground? And how do we leave this place better than the world that we came in on? But you can start to automate that. So like I mentioned before, that relay race where the product pulls into a warehouse and party A pays party B because it's tracked that object the moment it passed in. Maybe it was a beacon, maybe it was a sensor, maybe it was computer vision, doesn't really matter. At that point, you're checking everything in and checking it out, ship pulls into the port and party A pays party B half, and then the truck pulls into the retail location and party C pays party B, and then the drone brings it to your house, and when it drops it off, you say, if it's this big, you can leave it on the back porch, you predefine it, it's your spatial domain, right? It's your web space. If it's this big, land on the roof. If you're tiny and actually I need it right now because I'm making something in the kitchen, I can actually have a window just open up, you can fly it in, just drop it in front of me. Thank you very much. Permission space, trusted space, smart space, integrated and networked. So then the question starts to become, I know some of you asking, well, what kind of impact does it have in the world? Is it better? Is it actually better? I mean, it seems better, but the way that we're defining better these days is questionable. And so at least the UN has said, well, here's a bunch of ways we think we can make the world better, right? The UN sustainability goals. And Versus is actually working with Yale and a number of others on how we can apply this to tracking carbon output at the country level, at the city level, at the level of your home, and even every appliance, so that there's actually a fighting chance for us to meet the Paris Accords within the next decade. And so the impact of this is that you can truly actually get to a completely novel idea, not just smart spaces, but smart spaces connected together as nodes in a giant network. And this network forming a smart world. Idea that has never been possible before until the nervous system of the internet was built. Really, we need that information and that effectiveness to move past the screen and into the world around us. Of course, it's not just about one world, is it? I mean, we're on the moon, but it's not the moon. It's a representation of the moon. We're an entirely virtual world, right? So the metaverse is an infinite number of virtual worlds, as we've read about in our stories and seen in our science fiction. The power of a spatial domain is that those addresses are no different than the physical addresses. Turns out the whole thing is virtual. You just happen to be mapping some of the virtual stuff onto physical devices and at physical locations on Earth. This actually allows us to port and jump from this virtual world to any other virtual world, or in fact, even be able to bring any object or asset or character to any other environment in any other virtual space, as we've seen in movies like Ready Player One. And you move between web pages today. Well, that's fascinating. If we went back 100 years and went to the librarian and said, can you get me from the page in this book in this section to the page in this book in this section by clicking on it, they would say, well, you're insane. I don't know what you're talking about. But that's what hypertext did. It made text linkable and referenceable to another page. Okay? Well, I have a hyperlink right here. And instead of me just teleporting from that point where I entered this room to the stage, maybe I could teleport to that planet out there, or to that solar system and galaxy over there. An entirely integrated network of smart spaces, of web spaces, universes upon universes. And some will have laws, like you can't bring a lightsaber into Harry Potter's world, right? Maybe in others, there's worlds where you can bring Harry Potter and you can have Luke Skywalker and you can battle it out together. Everything that we've sort of seen in these sci-fi stories is actually possible now with some very simple functionality that has to do with the possibility of being able to network space instead of networking pages. And from there, you get all the power of these hyper exponential technologies like AI, spatial computing, like sensors and beacons in real time, being able to track our behavior. The power of blockchain and other distributed ledger technology to protect our identities and our privacy and security and secure these spaces. So governance. In the end, how do we actually deal with these scary things that we feel are coming as well? Drones and bots and AI and biohacking, and then privacy regulations with GDPR. I've got to click every time. Yes. Take whatever, I don't know. California's got new ones. Japan's coming out with new ones. Facebook gets fined $4 billion. Google gets fined $1 billion. Turns out Roomba is selling the information of the maps of people's homes. Of course, we don't trust any of these. This is the dystopic future that we fear. And we're talking 1 billion drones and 50 billion AI-enabled cameras in the next 10 years. So Everyone is taking a fragmented approach to resolving these. And there's no possible version of this where a fragmented approach is going to resolve it. So what we measure, how we measure it, what can be done with it is a question of governance, but it's a question of spatial governance. Where can these drones fly? Can that camera track my information? Who has access to these vehicles at what time? Who is this person trying to access this IoT device? Do I know this AI? Where are those bits coming from? Spatial. And part two here is fragmented approaches to interoperability. Talk to smart cities that are trying to develop all the time. Guess what they would like to do? Share information with each other. How is your mobility working? Can I see your data? They want to be nodes on a network and part of a smart world, but they really can't because there's entirely fragmented approaches to this. They think, oh, I'll call Microsoft, maybe they can figure it out. They can't. Fragmented approaches to platforms, AR, VR, headsets, AI, IoT, different devices. How do these things work together, right? We've already kind of discussed this. And economies, not just human economies, but machine-to-machine economies, right? Where the smart car is paying the smart parking meter when you pull up. It's got to be automated. And virtual economies where this experience may be paid for, or we may find or capture something in this room. We want to keep it in our inventory, and it's actually an asset. I need to know that someone else can't just destroy it or take it or remove it or alter it or change it. So the way we handle this is rights. And it turns out rights are kind of a tricky thing because when we tend to talk about them, people do something like this. Oh, there's civic rights, and then there's public rights, and there's different, and then there's private rights and personal rights, and there's different kinds of rights. But the whole trick to rights is to think of them as nested. Make sense? Personal rights are embedded in my private rights, which are impacted by the public laws around me. So right now, even though I'm in a virtual world with all of you, I'm actually sitting at my home in Los Angeles. And there's certain things that the owner of the building that I'm in actually has to do legally, their relationship with the city. And there's things that rights that I'm also sitting in that have to do with the state, sitting in multiple rights frameworks, and in fact, in the entire country, as a citizen, as a civilian. So once you start to think of rights this way, you can start to program all kinds of things. This is the way that most smart cities think about how they're going to be built today. In fact, your city. Oh, there's a physical world. You add 5G, and then IoT, drones, cars, robots, holographic content, AI, cameras. That looks terrible. We needed a spatial governance layer. Now, the spatial governance layer, when you blow it out, looks like this. Governance, it turns out, in rights management or any sort of control that is spatial is about three things: location, and identity, and activity. You kind of see over here on your right, there's a physical world, there's a sort of 5G layer, and then there's a location layer. You can see your spatial domains there. There's an identity layer. Every person and every object gets tracked. The question is, can it be tracked in a way that maintains my privacy? And I trust it. Over on the right, you see trust, interoperability, privacy, and security. That's our TIPS framework that uses distributed ledgers and encryption and other types of technologies to protect you as you're moving throughout the world. And then there's an activity layer, which uses that hyperspace modeling layer, which everyone can build their applications on, make whatever types of money they want. Both public and private entities can do it. It's part of an open standard that we're developing and putting into the Spatial Web Foundation, much like the World Wide Web Foundation hosts HTTP and HTML and XML and other technologies that we rely on today to interoperate. And then you can put everything on top, and you can now ensure trust, interoperability, and privacy and security by default. The challenge we've had today is that all of our application development on the web has been about how to extract value. But values were never built into the protocols themselves, and protections for identity didn't exist because there is no identity on the web. The identity is the identity that you create on a company's platform that they own. But in the spatial web, you log into the world. You log into the web, you log into the world, you log into the metaverse. So it becomes imperative that your identity is your property, not just privacy, but property. It turns out with location, identity, activity, you can define any sort of behavior because it all turns out to be where can who or what do what and how. So between all these various devices and interfaces and platforms. Why? Because it follows a biological model. Blockchain ends up being the communal sort of hard memory, right? And AI ends up being the brain, right? And natural language processing and chatbots. R&D are sort of the eyes, IoT is the sensors and the skin, and actuators and robots are the arm muscles. The bones and the muscles. But what you need is a digital nervous system that can communicate between them. This is a multi-sensory biological model. Well, it turns out we're turning the whole planet into this. And what's bizarre is that if you'd ask anyone in any one of these industries, the relationship to the others is, they're not going to say, well, it's very similar to a biological model, but look, there it is. As if evolution prefers one type of structure above all: network structure, web. And we've been building all this time to get to a spatial web because that's most like what nature prefers. That's how it maximizes interaction. That's how it maximizes collaboration. That's how it maximizes coordination. Systems that are naturally aligned with each other, that incentives can be structured to keep them working well together. And this is the promise of a sort of smart world that the spatial web enables. Interoperability combined with spatial management that fosters trust and multi-party collaboration, which unlocks network effects, exponential value, and enables a smart world, ultimately an autonomic digital economy. Of course, when we take this across the not only one planet, but the billions of virtual worlds that will exist. There's 3 billion websites today, right? It's just absolutely staggering when you start to think of environments like this being networked and where we might be able to bounce and jump to next. So we have an amazing advisory board. Jay Samet from Deloitte, there's Peter Diamandis from XPRIZE, Harry Kluwer is one of the top roboticists. John Havens is the executive director for the IEEE, it's one of the largest standards bodies. He's head of ethics for AI and autonomous systems. Liza Lichtenberger is an amazing AI researcher. Paul Kim's from Blockchain Industries. Kathy Hackle from Magic Leap, Denzel Fagelson from Apple, Tony Parisi from Unity, Ted Shilowitz from Paramount, Anselm Hook from Mozilla. We'll with many different open groups as we can. Mark Meadows is one of the original sort of AI chatbot pioneers. Carolyn Hull, who's actually just had to leave us because she's working with the mayor's office on smart city stuff. Chris Colo, who's the executive director of the VR AR Association. There's our Dr. Tom Furness right there as well, who's been a great sponsor of us. Andy Tim, who's the former CTO of PTC, one of the largest IoT companies in the world. Jennifer Kennedy is works with World Economic Forum, and Jorgen is one of the top IP specialists, formerly of SAP. We are looking for more people of color, and we're looking for more female representation to expand our advisory board. So please, if you've got someone that you think would really love to work with us, please reach out to us. There's both the nonprofit side, Spatial Web Foundation, and Versus, which builds commercial applications on top of that to sort of set up these early integrations. That's something that we really would like to look for. So there you kind of see the 1-2 punch. There's a Spatial Web Foundation, which is kind of like the Linux, Linux to the Red Hat of Versus Labs. It sets the open standards. It deals with the spatial domains. In fact, the former CFO of ICANN, who built out the nonprofit entity that runs all of the web domains today, is our CFO over at Versus. So the HSTP protocols and the HSML protocols are all being held over here. These are going to be held in trust for the planet. So this will be a nonprofit forever. And then on the other side, we're building out platforms and application and doing sort of enterprise integrations with backend systems like SAP and Salesforce and Microsoft and others to make it easier for industry and enterprise and governments to start to adopt that scale. And that is it. Thank you so much for your time and attention. I don't know where you're coming from, what part of the world you're in, but if you've been staying up late, thank you very much for giving me your time.
Well, thank you so much, Gabriel. Thank you so
Yeah,
much.
Daniel, thank you. It's such an honor. I appreciate it.
Thank you for
Fantastic.
persisting with us. Absolutely. Thank you for persisting despite technical problems and road
Oh, thank
traffic.
you everyone for waiting.
I'm so glad we waited around. That was very, very enlightening, and it's interesting to get a deep insight into the work you're doing for the spatial web. Such important work, and good to know who's doing it and why you're doing it. I love the fact that it's open. Thank you so much
Yes.
for that. Big
Thank
round of
you.
applause for Gabriel
You're
René,
all
please.
unmuted if you want to give him a round of applause.
Yeah.
Woo!
Very nice.
Good.
Yay.
Fantastic.
Yay.
So much.
Amazing.
Gabriel, you've obviously been following a little bit what we've been doing with Educators and VR.
Yeah.
We're also kind of bridging the gap between not-for-profit and for-profit. We've chosen the title social profit. So we're a limited company. We need to handle monies, but our values are very much social. I'd just like to open the dialogue and see if there's any way we can collaborate with you. We're very much on the education side of things, not industry, but maybe there's some overlap. We have a growing community. If there's anything we can do to support you, and maybe vice versa, we'd love to look into that at some point.
Absolutely. We'd
Yeah.
love for you guys to become members of the Spatial Web Foundation and help.
Oh, we'd be honored.
Work that we do is setting up future generations for how and what and in
Perfect.
we need to educate the
Wonderful. How do we do that? How do we become members of the Spatial Web Foundation? How would we do that?
yeah. No, I'll reach out to you.
Oh, fantastic.
We haven't started. We're going to be doing it in summer. We'll absolutely stay in touch and make sure you guys can see it.
Okay, 1 second. Sorry, my right controller has just died. 1 second, please. Switching batteries. I've been cycling through batteries all week. Here we go. 1 second. I got my hand back. Okay, good. Yeah. Yeah, Kent has a question, please. Kent?
Kent, you need to unmute yourself.
I see. Okay.
All right, can you hear me now?
Perfect. Yes.
All right. So thanks for the presentation. It's really excited to see all that you're doing. One of the things I didn't see was anything about WebXR or WebAssembly. Just wondering if you could talk a little bit about how you see WebXR and WebAssembly fitting into what you're doing.
Thank you. So the challenges we see with WebXR and WebAssembly is a bit of a philosophical difference. There was a lot of work being done in the early 90s by all kinds of parties to optimize performance in websites. Turned out that that when the cloud emerged, all of those approaches were wrong. The challenge with WebXR and WebAssembly as a way of functionality over HTTP, in our opinion, is a little like sticking wings on a car and hoping that you can travel around the world. You can probably get it to fly in environments, like this, but there are distinct limitations that do not allow it to, let's say, really fail. And so, what I'd like to see over time is the ability to work together with Mozilla and other folks working in WebXR space, how to add adapters on top of HTTP instead of HTTP, because then you can integrate all of those benefits and essentially extend the capabilities into the spatial web as opposed to sort of trying to spatialize the current web.
Cool. Yeah, that makes sense. And one other quick follow-up, because as I'm watching this presentation, I'm kind of sitting back and I've done a lot of look at privacy issues, and the thing that I'm struck by is that it just seems like we're moving towards this world that pretty much more and more of stuff is going to be tracked, objects, all sorts of data. What do you see in terms of the specifically the third-party doctrine, which is in the United States, it's the law that essentially says any data you give to a third party has no reasonable expectation to be private. So that in some sense means that you have to move more towards this, storing the data locally so that you're not giving it to a third party. And that, because if you want to track this stuff, then it seems like we're moving into this dystopic world that, I don't know if there's things like homomorphic encryption or, distributing things out into the web, but it seems like more and more stuff is going out into the web. But the thing I struggle with as I watch a presentation like this is that it just feels like a privacy nightmare, even though you say it's going to be, this, but I still think that the fact that it's going to be this exponential increase of data being tracked, how do you architect a system that actually maintains privacy in this vision?
Important pieces there. Beyond homomorphic encryption, which is pretty exciting, there's two functional challenges. So let me try to approach this from the right angle. How many people here have seen The Great Hack on Netflix? Anybody?
No.
All right. So
I have, yeah.
how many have heard of
Yeah, I've seen that.
Cambridge Analytica?
Yeah.
Mm-hmm.
So good. Couple over here. So turns out that there was this group, Cambridge Analytica, which was mining data outside of Facebook through third-party applications, which was used to profile tens of millions of people, that then was reselling that data to all kinds of third parties, including the Trump campaign and others, which became the basis for a lot of the fake news content created in order to alter certain people's opinions in order to sway their vote. So one of the most dangerous things that's happened in the history of humanity was the lack of attention and the lack of regulatory policy that existed, whereby Facebook, a private entity, could essentially allow another third party to back channel all of our private information and resell it into a private market that can influence political campaigns. So we have a massive amount of work that needs to be done in the regulatory space. Laws actually need to be written around it. This is where GDPR and privacy regulations are really starting to do work. So Facebook got fined several $1 billion. Google's getting fined $1 billion. These fines are going to continue to go up. So the pressure points are increasing around, oh, now you're collecting biometric information. Oh, you're a Fitbit. Oh, you collected this information. Oh, Room collected this information. The lawsuits are starting to spin out of control, and the regulatory environments are starting to spin up. So the cost of storing more and more highly personal information is going to become risky because they're honeypots for getting hacked, right? So even though right now it says, well, hey, whoever takes information, you shouldn't have an expectation. But the problem is someone's going after that data. Facebook and Google and the rest that are counting on storing third-party data, that becomes increasingly personal. Mood tracking, the expression on your face, pupil dilation, galvanic in response. I don't see a version where in 10 years these guys even exist if that's their basis of their business model. They're either going to get sued out of existence or they're going to get regulated into a corner. They already know this, which is why they're trying to move to other types of services. This is partially why you're seeing Facebook going into crypto. It's why Google's pushing cloud services. They're going to maximize the data that they have because that's their oil du jour. That is not a sustainable business model over the next couple of decades. So that's part A. The deeper the data set gets, the bigger the honeypot is, the more hackers and more risks that you're taking. And then the government and lawsuits and everything just start to close in on you. So every hack that gets worse is going to become a higher and higher risk until everyone. So that's just unsustainable. Two is this idea of decentralized identifiers. If you go look up DIDs, you're going to see Microsoft, IBM, and about 30 other companies now supporting a new sort of identifier standard. Now, if you think about it, the URL is actually the most popular ID used in the world. Like we use it for more interactions at greater scale, and it's an entirely open standard, and it's 100% reusable and repeatable. Whereas everyone else has proprietary IDs and identifiers for physical things and for our personal profiles. So there's a new approach to decentralized identifiers that enables third-party verification of something without disclosing certain private information. So that's the second part. Have a look at that. The third thing is that ultimately the laws need to transition to the point where we are not providing third parties the majority of our personal information. That information is our property. So it's less about privacy and becomes more about property rights. Property rights are going to need to define that this avatar is your avatar. It's not the avatar of the engaged platform. Right? You can like take it somewhere else. And so ultimately, all of the assets, objects, inventory, our identities need to be able to be defined as property, like physical property is defined in the world. So we need digital property rights. This is going to be a monumental shift that's going to occur, I think, over the next decade or so. And the Spatial Web Foundation and others will actually be working on legislation, lobbying for these types of changes. And it's why we have a number of ethics folks on our board, and we're certainly looking for more. So if you start to think of the sort of feudalism era around how we gained property from outside of the kingdoms that we lived in, these are just digital kingdoms, and we're digital serfs of the day. And so these rights actually need to change because the companies operate globally outside of any regional restrictions, right? It's very difficult to set global policy on Facebook or Google or anyone else. So we see the technical capability is there with decentralized identifiers. The honeypot of data becomes a greater and greater risk. So in fact, what happens in the future is when I walk into Whole Foods right now, oh, I got a bunch of cameras. I'm going to track all your stuff. I'm going to analyze your behavior. I'm going to try to figure out what you want. But don't do that. That's a waste of time and money. I'll just tell you when I get here, I will grant you access to all of my information. I've walked into the spatial domain. While I'm here, you can have access to all this information about my latest health updates. By the way, I'm not gluten-free anymore. That didn't work. I love pizza, right? And so now they've got access to real-time information, updated information. They're pulling it from me, not from them. They don't have to store it. And then when I walk out, they don't have it anymore. And by the way, they don't need it. And while I'm there, they could offer me a 10% incentive for sharing a certain amount of information, maybe pulling from my medical records or whatever. So once you start to network these data sets, but you use spatial domains to provision their use, it's actually better for the advertisers and the businesses. They've reduced their risk. They've got access to updated information, and it's all spatially done. So they're very optimistic about this. Now it's up to all of us to actually create these pressure points on these businesses and on our governments and to start to create legislation to support them. But we know this is not a sprint. This is a marathon. So what we see with what we have today is the technical capability. We see that the regulatory environment's heating up to be able to protect this. The business incentive is merely just going to evaporate because the risk is going to be too high.
Cool. Yeah. Thank you.
You can get on Amazon. There's an entire section where we talk about identity as a shift from a geospatial, what do we call it, a geocentric view of the galaxy, where the sun it looks like the sun's rotating around the Earth, and the Earth is at the center of the galaxy. That's Google, that's Facebook. We're all rotating around them. Turns out the sun should be at the center of the galaxy, and everyone else should rotate around us. So this is like a shift from geocentric way of looking at the galaxy to a heliocentric way of looking at galaxies. That's how we need to look at our data. It's a big philosophical shift that was back when Galileo locked up for it.
Yeah, Copernicus. Yeah.
Copernicus as well.
Thank you, Gabriel. Any other questions? Not for now. I'm going to ask some questions. I'm always good for questions. Let me come up there for a minute. All right. I'm still learning the teleport. Okay. All right. Question. Obviously, my background is in education. Educational institutions. How does all of this affect us? What should we prepare for first? Can we accelerate? Can we adapt quickly? How does this affect how we interact with our learners? Yeah.
So I think that the greatest challenge for educators over the next couple of decades is going to be how to lubricate our thinking in the most creative ways. So what ends up happening a lot of times with technology is we tend to think of how to solve yesterday's problems with new technology. But that's not really what those technologies tend to excel. they do a better job than whatever happened before, but then they do something else entirely. In the beginning, when we first started making cameras for film, we filmed stage plays. Now you can see stage plays without having to go to the play. But then we realized, we can edit this stuff and totally change the sequence and change multiple perspectives, and cinema emerges as an entirely different format. Even though you could still use a script, had nothing to do with the play structure. It had nothing to do with it. That's the challenge that educators face. It's important to think that far outside the box. Really try to get wild with it. What happens if you have the ability for, let's say, children, just to start with what we know is lifelong learning, to be able to bounce in and out of every scale of information, from the nano to the the quantum to the universal scale, and or be able to bounce through every single historical experience, or every single fictitious narrative. And so the question becomes, with that range, it's something we've done in other formats. We've done it in books, we've done it in film, and we've done it with visuals. It's now going to be experiential as opposed to informational. And so there are ethical considerations there. There are creative considerations. There are design questions there. And I think it's a question of really workshopping that. Watch sci-fi movies. Try to watch the most advanced sci-fi movies and say, when Spock is in his little pod learning, what is he actually able to learn? Ready Player One, they're at a school. What are they actually able to learn? Sci-fi thinkers have done really good work at thinking about some of where these possibilities might go without the constraints of the technical requirements. But those technical requirements are going to get addressed by more billions of dollars that have ever been poured into a single category of technology outside of AI in history.
Okay.
This,
Very
the
interesting.
sky's the limit, but we're already on the moon. So the universe.
We have a tag. We have a strap line with educators. The sky's no longer the limit.
Exactly.
Yeah, pretty much, we're up here.
I think by doing events like this is so progressive and so cool, and it's important we get in here and mess around and figure out all the kinks and figure out how, like, part of this is working really well, part of this is incredibly awkward, right? And so understanding that, ourselves allow us to then think about how these designs need to work in the future. And so this is pioneering, right? This is what pioneering looks like. It's very exciting what you guys are doing.
Thank you very much. Anyone else before we close? I'm aware, Gabriel, you may well have engagements elsewhere, and so I think Kent just grabbed his heart. He ripped his heart out.
He pulled his own heart out.
Wow.
How do I get a hold of these slides? Oh, jeez.
You can probably pick that up. Can you pick that up? Is it shareable?
Perfect question.
No, not at the moment. The slides, Gabriel, are they shareable? Oh yeah, you've got it. Nice one.
I will send over a version of the slide deck that you can share. Yeah.
Lovely. Okay. Thank you very much. In that case, we love you.
Biological. That's amazing.
Not quite as romantic. All right, Carlos, were you asking for the slides? Who? Yeah, thank you. Indeed.
Well,
Indeed.
If you'd like to learn more, please check out the Spatial Web book. It goes into all this stuff in much greater detail. You can get it on Amazon. If you love it, please write a review. If you hate it, please contact me and tell me why. So I can improve on it. And you can always reach out. I'm on LinkedIn. I'm on Twitter.
Wonderful.
And soon to be in a metaverse near you.
Yeah, near you. Coming to a metaverse near you. Lovely. All right.
Thank you.
Thank you very much, everyone.
All right.
Thank you.
Thank you very much.
Bye, everybody.
Thank you,
It was a trip
everybody.
home to Earth. Thank you very much. All right, thank you. Chris, thank you very much. Engage.
Yeah, thanks,
You guys have
Chris.
been amazing.
Take care. Take care. Good
Hey.
to see you all.
Stop
Thanks,
that.
Daniel, too. Get some sleep.
All right. See y'all.
Indeed, yeah, absolutely. I intend.
I am ready
that. I
to
don't
sleep
think I have a choice.
hard tonight.
Exactly. All right, Chris, just checking. This was our last event, right? In here?
Yes, and then
Or do we
we've
have
got
one more?
Nope, that's it from me. And then I've got
Ryan
Ryan
Schultz.
Schultz at
Ryan in the
tomorrow
morning. Yeah.
very
perfect.
early,
Okay.
6 a.m. my time.
It's 1
Yeah.
o'clock my time. If you want to sleep, I think I might be able to handle it, dude.
Oh, dude, no. This is a long time away.
Okay, well, cool.
We're
All
good.
right,
Yeah, I'm going to bed now so I can get up for that one.
all right.
Cool. Cool.
All right,
I'll see you
wonderful.
there, dude.
Thank you so much,
Okay.
everyone.
All right. Take
I'm
care.
gonna
Safe
hop-
trip home, back to Earth. David, thanks for making it.
Nice.
All right, I'm gonna drop that down. And oh, Chris, can you shoot me up to Earth if I jump on a chair? Can you shoot me up to Earth?
Yes.
Do I jump
will shoot
outside for
you
that?
away to Earth. Let's go outside. Let's send you away properly.